Good afternoon. My name is Maher Damak. I'm the co-founder and CEO of Infinite Cooling, and our company works on cooling towers. So what are cooling towers? If you look at any industrial facility, you often see these plumes rising from a bunch of systems that look like smoke. Most of the time, that's not smoke. That's just water vapor that's condensing and forming that white smoke-looking thing. And those are cooling towers. They evaporate water to provide cooling. And we're working to make them more efficient. So what we're looking for at this time is growing our revenue. So we're looking for new customers, channel partners for sales, as well as manufacturing partners. And really, we started working on this problem because cooling towers are critical systems in a bunch of industries, going from power generation to industrial facilities like chemicals, pharmaceuticals, data centers, and carbon capture as well. And they account for over 50% of all water consumption in industrial and commercial applications. They've also recently become more of a bottleneck to production in a lot of industries. So we've seen plants having to shut down or curtail their production because they can't get enough water for cooling. And finally, they have a direct impact on the efficiency of these production facilities. So basically, a better cooling tower leads to more production. So we're addressing all of these issues in a couple of ways. So typically, our first step is we start with our cooling analytics product. And the reason is we noticed that basically there's very little monitoring that's done on these cooling towers. And as a consequence, literally every cooling tower we've ever seen was operating well below its optimal efficiency. And that's just because they don't know what's going on in those systems. So we now sell a suite of sensors that can be added to these cooling towers, and we developed proprietary algorithms that use physics and machine learning to do real-time monitoring, optimization, and predictive maintenance. And the main impact is energy savings, water savings, and usually most importantly, increased cooling capacity. So you can cool more with the same system. And that's basically a software product that we sell as a subscription. And then going back to those plumes that are ejected by cooling towers, that's where the water consumption is going. So that's where we have a technology that we developed at MIT and patented to capture water from the plumes that are coming out of cooling towers. So for those customers who have these water issues where it's bottlenecking their production or it's costing a lot of money, we can tap into that stream of actually distilled water because it's evaporated and then recondensed, capture it back, and then we can use it for a variety of applications. The other advantage is also getting rid of that smoke-looking thing, which is desirable for a variety of reasons in industry. So these products are already, engineered. They're already deployed. So I'll show you a couple of case studies. This is a natural gas power plant that we're working with in Wisconsin, over 600 megawatts. And basically, initially, they contacted us because they had a water issue. They were already using treated recycled water as makeup for their cooling tower. But even with that, they didn't have enough water. And they had no idea how the cooling tower was affecting their performance. So we installed our TowerPulse solution. It's in just a few days because these are wireless sensors that are externally mounted. And we immediately found out that their cooling tower was operating only at 80% efficiency. And our algorithms were able to determine what were the causes of that drop in efficiency, which in this case was basically some airflow issues where they needed maintenance on their fans. And their water treatment program was not adequate, so they were building scale. And they had some issues with their controls as well. So with these very simple interventions, once they knew what they needed to do, they were able to save about $500,000 per year. And that's mostly coming from increased production, because with that more efficient cooling tower, that power plant can generate more power for the same amount of fuel. And then there is also a drop in maintenance costs once you start doing predictive maintenance instead of reactive. Here's another example. This is a nuclear plant in France with EDF, which is the world's largest nuclear producer. So these guys came to us because they had a water issue. So they've had to shut down plants multiple times in the past few years because of water scarcity during the summer. And that costs a lot of money because actually when you have these drought events, it's very hot, so everyone turns on the air conditioner, so electricity prices spike, and that's when they cannot produce. So they're losing a lot. And just to give you an idea, it's like losses are in the tens of millions of dollars per day when they have these issues. And there's also some new regulations in France about reducing water consumption in industrial facilities. So basically they came to us and said, look, in these nuclear plants, 95% of plus of water is consumed in the cooling tower. So if they want to have any measurable impact, they need to address cooling towers. So we deployed actually a pilot with them at an operating nuclear plant. Basically one of our water collection modules. We put it in for about a year last year to test it in all sorts of climate conditions and operating conditions. And we were able to validate our performance, both from the amount of water that we collect, as well as the quality of that water, the fact that it's demineralized water that they can then use for their boiler feed as well, not just cooling towers. So with that, now we're scaling to a full-scale facility, but that's helping them already meet their goals, be more reliable, and reduce the water treatment costs. So these are just two examples in the power industry. We have a number of other customers in a variety of industries, many types of power generation, but also chemicals, pharmaceuticals, food and beverage, metals, manufacturing. As well as carbon capture. We can work with DAC systems as well as point source capture systems. And this team was founded by myself, Professor Kripa Varanasi, who you heard earlier, and our CTO, Karim Khalil, all out of the same lab at MIT. And then we have on our board the former CTO of GE, Mark Little, and Carmichael Roberts, who led our previous investment. So right now, what we're looking for is growing the business. So looking for new customers, whether it's industrial plants, power plants, data centers, carbon capture plants. In any of those, we can help and replicate the case studies that I showed you earlier. And these products are, already we know how to make them. There's no more inventions that need to be done. Like we already know how to make and sell them. And then we're also looking for potential channel partners to sell these products to industrial customers. So these are organizations that are already selling to our target customer base, or organizations that are involved in cooling towers, like manufacturers or water treatment companies and things like that. And we're also ramping out our manufacturing for our product. So we're looking for contract manufacturers as well, with who specialize in sheet metal work and assembly work. So yeah, if you're interested in any of those things, come find me at the table after the presentations. Thank you.